Okay, this lab is also from your lab manual. Determining the molar mass of a volatile liquid begins on page 79 of your lab manual. And so we're kind of stepping back to chapter 10. This is a gas laws lab. PV equals nRT. Pre-lab is on page 81. Procedure on page 83. The first thing I need to do is get a clean 125 ml flask and fill it to the brim with water. We are going to ultimately fill this flask with a gas. And you guys know the gas, any gas would take the full volume of this flask. So this is a 125 ml flask. That means it should be about 125 milliliters at the top. But we need a more precise measurement than that, okay? So I'm going to completely fill up the flask until it overflows. And I'm going to be covering this flask with aluminum foil, so I'm going to do that and see if a couple of drops ran down the side. Okay, so let's see the volume of water in that flask. Let's get the digital balance away from what I'm doing. Okay, I'm going to carefully pour it. You guys did this when you measured the volume of your airbag. And I want it all in the graduated cylinder. So I'm going to do, my goal here is to pour exactly 100 out. We're going to write that down on our data sheet. Okay? So, on your data sheet, trial 1 volumes, that's 100 plus, let's see what is left in here. Wow. That's a 125 ml flask. Oh, that's not made to fill to the brim. Okay, now I have, let's see. I got 45, hang on. Got about 45.2 milliliters. So that means the volume of the flask, that's our 45.2. The total volume is 145.2 milliliters. And we're just going to do that one time, so the average is going to be 145.2. Now, moving on to part B. It says to get a 600 ml beaker, add 300 mils of distilled water, a few boiling stones. I didn't put the boiling stones in, but that's fine. And I've been heating this over a hot plate. Our Erlenmeyer flask, we need to clean it and dry it. Pause it here. And we're going to dry it. I'm going to put it in the oven for about 5 minutes. Okay, that has been dried, heat dried. Now I'm on step 9. I'm going to cover the flask with a piece of aluminum foil. I'm not going to use the rubber band. I'm just going to put the aluminum foil on there really tight. And step 10 is determine the mass of the flask, the foil, and the rubber band. So I've got my balance here. I'm going to write this on my data sheet. 78.934 grams. 78.934 grams. That is the flask, the foil cap, and you can mark out the rubber band because we don't have that on there. Then I'm going to get 25 milliliters of my unknown, and this is step 11. And you don't need an ID for the unknown because you're all doing the same thing. And you're going to put about 5 milliliters of your unknown in the flask. So this is my unknown. And I'm going to use my graduated cylinder And I'm going to measure out about 5 milliliters and put it in the flask. Okay. Put the same piece of aluminum foil needs to go back on there. And then we're going to poke a few holes in this flask so that the vapor of the unknown can escape. So I just have a small paper clip. I'll poke some holes in the flask. I'm going to attach my flask, clamp it on. Lower that, and what I'm going to do is I'm going to gently heat up the liquid, and it's going to evaporate. This is going to take a little while. All the liquid's going to evaporate, but the flask is going to be completely full of our unknown liquid. So we lowered the flask into the sample. That's step 13. We want to get it so that the water level is as high on the neck of that flask as we can. And so what that's going to result in me doing is I'm going to overflow some of my water so that I don't make too big of a mess. Well,
Get you a paper towel.
it's not too bad. Okay, I want it in there as much as possible. And we're just going to continue heating this. I might observe some vapors escaping. We'll see if we can see the vapors escaping. The liquid I'm using evaporates at lower than 100 degrees Celsius, so I am monitoring this. There's no sense in having that water at a full rolling boil. Okay, and we're going to let that go for a little bit. Okay, so it's been boiling and evaporating for about 30 minutes. So had you been doing this in person, you'd been hanging out watching it boil for 30 minutes. We're going to measure the temperature of the boiling water. We're going to write that on our data sheet. It should be 100, but it depends on how the thermometer's calibrated too. We're at 98, 99. .5. Okay, now we're at 100. Yeah, 100 degrees Celsius. Okay, we'll let that cool. So I can touch it. So I'm going to go over here and write 100 degrees Celsius on the temperature. You could do 100.0 because it was right on. That's another significant figure. We need the barometric pressure of the room. Hey Siri, what is the barometric pressure of my location? 29.79 inches of mercury. 29.79 inches of mercury. You're going to have to convert that to atmospheres. So you have resources to look up the conversion between inches of mercury to atmospheres.
It's called the internet.
Okay. Now I'm going to dry this flask. So what we did is I put the liquid in there and we evaporated all of it. And so the flask was just filled with vapor. And I'm going to reweigh it so I'll know the mass of the vapor, the gas, that was in the flask. But I want to be sure it's dry. I don't want to weigh any of the water that's on the outside. And the holes in the top allowed, because it wasn't 5 mils in there. I can see a little bit condensing in the bottom, but that's fine. 79.264. That is the mass of the dry flask and the sample and the foil cap, okay? That is enough data for you to do the calculations to figure out the mass of the vapor by subtraction. The moles of the vapor is where you're gonna do PV equals nRT. And a molar mass, you know, is grams per mole. So you would divide those to figure out the molar mass. And again, we're gonna do one trial of that, and it's posted what all you're gonna turn in and how you'll submit that to me.